right, here we are again on Tuesday evening, man. Hey, we want to welcome everybody out there watching and tuning in tonight on our YouTube channel, Amateur Radio Roundtable on W5KUB.com is our website. And if you're watching out there on YouTube, you can also watch it on our website, W5KUB.com, and that is where the official chat room is. So, if you want to join us in the chat room, you need to go to W5KUB.com. We got some shortwave listeners out there. We'd like to hear from you. Send us an email to tom@W5KUB.com and let us know where you are and how you're hearing the station tonight. It's coming to you out of Monticello, Maine on 7490. That's WBCQ. I think I got a graphic here. There we go. WBCQ right there. And they always get a lot of snow up there. Yeah, I don't know if they got snow right now or not, but
it's coming.
That's what it looks like from time to time there, and it does affect the transmitter sometimes. Hey, and also, hey, we're on just about every podcast carrier out there. We've got people that convinced me just to put an audio podcast up. I didn't know why, but we've got a lot of people that like the audio podcast. They can listen to it at work or driving in their car or whatever. And we're carried just by about every podcast carrier out there. My graphics here doesn't have enough room on it, but you know, we're on iTunes and Google Play and iNet Radio and all the podcast carriers out there. Every day or two, another one picks us up and carries us. So check that out if you want to. Let's see. Need a favor from everybody. Let me see if I can figure out how to work this thing. Let's see. What am I clicking on here? There we go. I'm back. Okay. Hey, I need a favor from everybody. I need you to hit the subscribe button. Hit that subscribe button. I'll help you out. It's kind of down there somewhere. There should be a subscribe button. That helps us out a whole lot to find new people that are surfing YouTube, and they find us by the little thumbnails that you see over on the right side when you surf around on YouTube. So please hit the subscribe button. Hey, and hit the notify button, if you will, the little bell right there. Sometimes we come on during the week, and we will have some special live event coming on, and if you're subscribing to us and you have the notification turned on, you'll be told or notified, you know, that, hey, something's coming on here. So, yeah, do that for us. Join our Facebook group. We've got about 14,000 members in our Facebook group. It follows this group. Just search for W5KUB in Facebook search bar, and you'll find us there, and we'll let you join just like instantly, man. So join that Facebook group, and it's a great ham radio Facebook group. Hey, tonight, man, we're going to talk about, hey, I got my satellite station up and running. I'm not real happy with it, but it is running. We'll talk about that. Got a little video, and I got some pictures. We're going to build a curve tracer tonight. You may have seen a video that Alan did maybe months and months ago. We may play it again tonight about the curve tracer and how we can use it and everything. We're going to build one tonight on his show. And we're also going to talk about tonight, we're going to talk about our Pico balloons. We've got another balloon going up tomorrow, our last one, W5KUB-115 on APRS, and it's also KN9UQB. That's Jim's call, and that will be on Whisper. So we got so many balloons up, we're having to use different calls on Whisper, or, you know, man. But anyway, hey, it looks cold up there. You can see there's Todd right there launching one of the balloons this week. And I tell you, we were always taught here, don't launch a balloon if it's cloudy. If there's moisture in the air, don't launch a balloon. That looks exactly like some of the failures we had right there, but that may be a good day down here. You know, Todd's a meteorologist, so he knows what's going on. Maybe those are dry clouds. I have no idea.
Yeah, it's a dry cold.
That's probably just dry cold right there, man. So anyway, we're going to have some fun. We'll talk about that in a minute. We'll see where our balloons are. I know the one launched in Antarctica is moving about 100 miles an hour today, and it's trying to kind of break loose from, I guess that's a continent, isn't it? Continent of Antarctica?
Yes.
Yeah. It's trying to break loose from the continent there, but it keeps getting kind of pulled back. I don't know if the magnetic South Pole is trying to latch on to the track or what's going on, but it's having trouble breaking out there. Hey, Glenn, how you doing tonight, man? Hadn't seen you since last week, man. Come on in here.
I'm doing good. I mean, it's cold outside. I mean, seems like it got a little colder. We jumped straight from summer to winter with very little fall this year, and like it's been in the 20s or 30s every day this week in the morning getting up. But we're moving right along. I'm busting my tail on the book still, and things are going, real good with it. So we're kind of pretty much on schedule. And I'm thinking up some new ideas to talk about, like the e-ink displays and some of that stuff. That stuff is just really, really cool. One of the biggest things, of course, is it's super low power, and it even retains its image after it's been turned off. So that's something really cool for our low power Arduino type projects.
Well, that's cool. We're looking for projects. One thing that we have a shortage of is a lot of new projects on here. And when I first started the show, I wanted to have a segment like on home brewing. I'm a home brewer from years ago, and I want to try to get back to that and have more things where we build it. Kits are great. Kits are good. That gets you started. But hey, a lot of people make their own kits. I've got so many parts and stuff in the closet here that, hey, I find me something I want to build, and I just go in and grab all the parts and I build it. I don't have to order the kit. So.
Oh yeah. I think that's what I enjoy the most is, creating and building these projects for the books. That's probably the most fun part of the book.
Oh yeah. So I don't know. I'm going to try to get back into building there, and tonight we're going to build a curve tracer tonight on the show. Actually, it's already built. I'll give you a sneak preview. Here we go. Look at this. I'll give you a sneak preview.
Very cool.
There we go. Look at that. Even got test leads. Even got some new test leads that plug into it. Look at that. Got a plug on there and everything.
Well, hearing you talk about your satellite station, it's like,
look at
right
this.
after I finish this book, which will be towards the end of December, I'm going to be doing research and getting the satellite station up and playing with all of my new toys. So we're going to have a lot of little pieces that I'm going to be putting together between now and then as well. So.
Well, hey, and hey, my new toy, the IC9700, I turned it on for the first time, I think, yesterday or the day before. And when did I get that? Back in August, I think.
You got it in August because you won it at the Huntsville Ham Fest.
Yeah. So, it's just I'm so busy, man. I'm really busy. And, hey, I need help. I need some help from everybody out there watching tonight. We need projects. We need people that can talk about things. I don't have the time. I'm retired, so I don't have the time every week to find new stuff. So I need your help. In fact, the job it's a pretty tough job here, and I'm even considering maybe next year. I'll just give you guys a hint. Maybe next year, terminating Amateur Radio Roundtable. We've been on 9 years now. We've been on nearly every single week for 9 years. And it's just getting tough for me. I guess at my age, it's getting tough to continue with this thing. So I need help. I'm pretty much doing it, by myself, with the exception of, people like you, Glenn, that join us, and Bill. But I need help to bring in, segments and programs and people to talk about it and even help me plan it. So I don't know if we decide next year to terminate it. Maybe we'll just go to a non-live show, and maybe we'll do something once a week, twice a week, once every other week, and we'll post it. And then if you subscribe, it's on there, and you can watch it. A lot of people's videos aren't live, and our numbers have dropped off. over the years. We used to, 2 or 3 years ago, we had double the number of viewers that we have. Seems like more people are watching it after the fact right now. So anyway, hey, that's my thinking right now. But hey, tonight we're going to look at the satellite system there. We're going to talk about the Todd and the balloon launches coming up. Bill's in here; he might have some more information about it. And then we're gonna build a curve tracer real quick, and maybe look at a video that Alan put together. It's about a 10-minute video about the curve tracer and what it can do. Hey, Bill, come in here. Bill, are you still there? Come on in.
Yeah,
Bill.
I'm here.
Yeah. Now, Bill, have you got better internet tonight?
No, it's the same lousy internet.
Same, okay.
We're beginning to hear they ran the fiber cable past our house in August, and we're just waiting for them to figure out when they're going to actually have it available to us.
So they ran it past your house and missed you, huh?
Well, no one here has it, but
oh, really?
They're slowly implementing. It's through our power company, actually.
Yeah, they're actually running this. They're running fiber down my street now too, so I actually stand a chance at getting decent internet.
Yeah, well, that's great. I hope you guys get it soon.
It's going to be 2 gig service when we get it.
There you go.
Pretty phenomenal, considering right now it's 2 meg service.
Yeah.
Anyways, the word is that your second tracker, the one with the circular solar panels that are facing horizontal like a cylinder.
That one right there. There it is.
That
right there.
one is going up. That'll be W5. Yeah, W5 KUB-115. If the winds are light enough tomorrow, he's going to launch it early tomorrow morning. And so you might want to start up your script for that. What's the call? The whispered call sign on that one?
It's KD9 UQB as in Bravo.
So kilowatt Delta 9.
Uniform
Quebec.
Yeah.
Bravo.
Yeah.
Okay.
So Bill, I'm a newcomer to this. I've only been doing it about 3 years. You're the expert, but you always taught me, man, don't launch in clouds, man. And hey, we launched a couple of SBSs, and it was kind of sprinkly, and we lost them, and that was an expensive balloon. And we know we can't launch in bad weather. But now I want you to look at this. Now you tell me here what Todd's doing right here. That looks like some clouds to me. Tell me about the clouds.
Now they're not a thick cloud deck, but they are risky going through because you can pick up some ice.
Yeah, I was going to say those look pretty bad to me. But maybe it's more of a dry cloud. Maybe it's maybe it's not too bad down here. But at least I think all the other.
That's a beautiful.
Yeah.
That's a beautiful picture because it shows them actually launching a balloon that might actually have been W5 KUB-114 with Glenn's call, kilowatt Whiskey 5, Glenn Popeil. So they're doing great. There you go. They had a new Antarctic Sky Ant crew. Do you have names for them?
Well, we've got 6 people up on 2 other balloons, so we had to settle for Larry, Curly, and Mo on this one.
Oh, okay.
I mean, we got Huey, Dewey, and Louie on.
Well, the next thing about.
Yeah, we got Huey, Dewey, and Louie on one of them, and then we've got Daryl, and his other Larry, and Daryl, and his other brother Daryl on the other one. So we had to go with. Well, I can't even get. Man, we're Curly, Mo, and what's the? Well, help me
Larry.
Here.
Well, we still got Shemp in reserve.
Yeah, we do. We're down in mission control right now. Yeah. So we hope that 115 gets off the ground tomorrow, and this is what 115 looks like. This has got the circular vertical solar panels. If you look at that closely, that's the antennas. That's the top half and the bottom half that's wound up here on the styrofoam, And we just glued the tracker inside we just glued it inside there with some adhesive against the side of one of the solar panels. So we'll see. He's had good luck on all the other launches. They've worked well. So we hopefully this one will get out there and work also.
That's actually a really cool looking design. I'm really looking forward to see how that one's going to perform.
I played with that out in the sun, and no matter, I mean, the sun very low, near sunrise or sunset, I mean, it hits it just straight on. So
how much extra weight did that add to the whole thing?
Well, I think this guy came in at about 22 grams, 24 grams maybe. So it added some weight to it for sure. And even this other one, this is a 114. It's flying right here. I mean, that's the entire tracker there, guys. I had an old. If you look closely at that cell, that's a real thick poly glass cell. And
I've got about a dozen of those. I was playing around with those exact cells.
Yeah.
Several years ago, but they weigh 18 grams just by themselves.
Yeah.
So I never flown one.
Yeah. So
But they're sturdy as all get out.
You can't break it. And one of our I guess rules of sending our trackers down, if we put those little glass cells on there, they wouldn't have made it. They would have gotten broken. The guy at Customs would have picked one up and stuck his thumb right through it. It would have gotten broken. So I thought, okay, this is supposed to be 3 volt at 150 mils. The thing's putting out almost 5 volts, and it's really solid. I just got the tracker glued underneath the bottom of it there. That's the whole tracker assembly right there. It's 2 inches square, and that's the one flying right now off the coast down here. And tonight it was doing about 100 miles an hour or close to it.
Yeah, at about 36,000 feet.
Yeah. Oh, hey, and Bill, I just wonder. It seems all of them he has launched down there are around 35 or 36,000. Is that the has anything to do with the barometric pressure, or is it just? I would have thought helium might have took them a little higher. These balloons, reach.
Oh no, helium takes you lower.
Yeah, but that much
by about 2,000 feet lower.
Right.
Using helium and. Not only that, the atmosphere is, for a given barometric pressure, it's lower in altitude over the polar regions.
Yeah. So I was thinking, okay, hey, these balloons have basically been floating anywhere from 48 to 51,000 feet. I mean, these are flyers, man. So you take a few.
You're also running 8 grams instead of 18. So
yeah, well, that's true too.
It makes a huge difference.
yeah, I guess that probably does make some difference too. Yeah.
But the atmosphere is thicker over the equator than it is at the poles.
Yeah.
So for a given pressure, float pressure, you're going to be at a higher altitude in mid latitudes than you will be at the high latitudes. And believe it or not, south is still a high latitude.
Yeah, well, I'm just happy that all of them have reached float, and they all seem to be flying out there.
Now, the really cool thing is I've been reaching out to several whisper stations in Australia, New Zealand, and the McMurdo station, KC4USV, that is in McMurdo Sound, which is just due south of New Zealand and Australia. That's our big U.S. base there. They were operating transmit only on Whisper, but it didn't look like they were receiving anybody. So I sent an email to the QSL manager I found on QRZ.com and asked McMurdo to see if they could start receiving. And lo and behold, last night they did. And
that's good. Yeah.
They actually were picking up Glenn's call.
Yeah, I saw that.
Line of sight as they went near the base. And they were also picking up Todd's tracker as it flew within their line of sight range. So they were getting ground wave reception as both of them flew by McMurdo yesterday.
There's a
And I
question.
also have Bob Sutton, ZL1RS. He's the one that has these huge beverage antennas that are thousands of feet long that in his pastures and his because he's very rural and he has very low noise level, and he has positioned his beverage antenna south towards Antarctica, and he's starting to pick them up beautifully. He's going to fill in the gap when they get a little farther east. There's going to be a gap of receive stations, and he's picking it up great. The way he steers his antenna is that he has a series of electric fence poles with insulators that he runs his wire across, and he just goes out and moves them over by hand. He's got a little foot pedal on each one, and he just pulls them up, moves them over a few degrees, and jams them back to the ground and walks the hundreds of feet to the other end.
Wow.
So the beverage is really not a high gain antenna, but it's a very, very low noise antenna, and and he's very, very rural, and he's getting great reception on it. And VK5ARG is on with a very low noise location on a mountain in Australia, and our friend Mark at VK5QI, he's set that up to receive whisper to decode our flights, and he's getting a lot of good reception there in Australia with that station. And in fact, it was actually received here in Alabama by Shane N4XWC, and he's got a large beam antenna pointed that way, and he's got a low noise environment out in the country, and he's picked it up multiple times on several of the payloads, including your payload.
Well,
so we're getting a lot of really cool long distance reception of 15,000 kilometers or more. One was 19,000 kilometers, which is completely on the other side of the world, and a little bit beyond, long path from basically Antarctica all the way to Alaska, and lots of reports over the United States that are just almost 10,000 miles in distance, and that's really amazing for 10 to 20 milliwatts of output power. Oh, by the way, I want to thank you for convincing me to get that Regal spectrum analyzer.
Did you order the spectrum analyzer too? Man, everything I buy, you're ordering one. I need to get a kickback on this stuff, man.
I'm your best customer. Best customer, but it works beautifully and flawlessly, and I'm just having a ball with it. But actually, the mini spectrum analyzer, the mini SA, works pretty well, but it's so tiny and so hard to read that is wonderful to have a really big.
Bill, I've got one of those, and I've got the VNA and the tiny SA. I haven't even used the things. It's so small, and you got to click through so many little menus and stuff. And oh man, I don't know. I need something with bigger knobs on it.
The readings were comparable from the mini SA. I mean the tiny SA. I'm sorry. The tiny SA reading, at least on 14 megahertz, were pretty close to what I got in the Regal. The Regal is a little more got better resolution, but it really was comparable as far as measuring peaks and power levels and spectral spectrum. So I was really impressed with it, but I had to use a magnifying glass on it to see the display on that tiny SA. But for under $100, you really can't beat that. But the Regal is a true lab quality.
It looks good
with a calibration chart, no less.
Looks good,
and it really performed. It's very similar to my HP spectrum analyzer that weighs about 30 tons. My old HP, it's right up there with that. So I was impressed with it.
Well, you know, and you know, I
Got a
bought.
commission for just the items I bought that you've recommended. You'd be a very wealthy man.
Yeah. Okay. Cool. Cool. Well, you know, hey, tonight we're going to talk a little about the curve tracer, and you know, I bought that scope. I can't pronounce the name. F Nursey. I don't know what it is, but you know, it's a neat little scope. Probably could have done better, but so I build this curve tracer up, and I connect it up to it, and I'm not getting. I'm thinking it doesn't look right. I can't see the patterns like I'm supposed to, and I start thinking, okay, I need to be in an XY mode, and will this new digital scope go into XY mode? You know, all the old analog scopes, you got about 4 or 5 switches you flip, you know, to put it in XY mode and all that. Well, I finally in the menu I found it does have XY mode, and I set it, and with my curve tracer I can see the waveforms now, but the scope seems a little slow on the waveforms with the tracer, so I don't know. But we're going to build a tracer tonight. Hey, somebody asked in the chat room about customs. You know, God probably didn't have to go through any customs going to Antarctica, since maybe that's not a real country down here. I don't know. But, you know, hey, I tell you, I traveled a lot internationally, many years from here to Europe and back, and the Asia trips were the ones that would kill you. But I'm sure this trip was a pretty bad one that Todd had to make, because I guess he probably went in. I'm guessing he went into Germany or somewhere into Europe, and then from there he had to fly all the way down.
He went into Germany.
Yeah,
Tom. He went to Germany, and then to South Africa, and
right.
then they had a charter flight South Africa, and of course they clear everything.
Yeah.
You know that it's all scientific research equipment. And then they go down to a way station airfield in Antarctica, and then a ski plane from there to the German Neumayer station.
So yeah, he had, you know, he had a lot of flights. He had a lot of long distance flights to take, and hey, that's where I was afraid it was going to get broken. I'm sure in Cape, what is it?
And the airfare is about $20,000. So if you want to tag along.
Oh yeah, well. And you know,
can't you use your
he hand
flyer miles for that?
He hand carried all the trackers on. There was a bunch of trackers, man, and those things, some of them are. That's why we didn't go with the brittle, the ones that would break so easy. So I just knew somebody's going to pull it out of his bag and inspect it at Cape Hope or wherever that is down here, and you know, break it, and then it wouldn't have flown. So what we did was we ensured that it was unbreakable, pretty much, and. Looks like they're flying, even though they're heavy.
They're doing real good. I've been watching mine, and I think that's really cool.
Yeah. Hey, let me just mention to people listening out there in Troy, they probably have no idea what we're talking about. Our group flies some little, we call them pico balloons. They're small party-sized balloons with helium or hydrogen, and we have a tracker that we build and put under it, and that tracker will transmit its position and speed and altitude back to a Google map every 10 minutes, so we can watch this thing fly around the world. And it's pretty common now with this new balloon that we can watch the balloons actually go around the world a number of times. And you know, Bill, W5KUB 112 has been up now, I think, 167 days. Can you believe that?
That's great.
That's a lot of days, man.
Currently over China, or I think, or Middle East.
Well, I think that one may be over Saudi Arabia. We've got 113 that should tonight be clearing China, I would think, and probably going out into the Pacific. But and it's only been up about 38, 39 days. But I'm surprised. 112. 167 or 168 days now. So, you know, hey, back in the early days, Bill, if you could get 1 day, and if you could get 10 days, you know, you did pretty good. You know, if you get 20 days, you might make it around the world. Now, man, it's like, throw it up there and forget it, man. Just check it every month. You know, it's still flying, you know. Okay.
That's amazing.
Yeah.
Well, what's the altitude on that highest one? Is it still above 50,000 feet?
Which one's? Oh, the 112. It's somewhere around 48 or somewhere in that area.
Yeah,
Let
so
me
it's
see.
still pretty much above most of the storms.
Well,
and
you
stuff.
know, and it's still at a good high altitude. It's varying. I mean, let's see. Right now, it's showing. I'll put it on here. Right now, it's showing it is at what is that? 49,803, and that's not bad. And when it started out, it flew at around 51,000 for the first couple months.
Yeah,
but I've seen it go lower. I've seen it go lower than that, and then it comes back up and it gains the altitude again.
Can
that's
you zoom
quite
in
impressive.
on the ones in Australia?
Yeah.
I mean, the one in Antarctica,
let's see.
where the position is now.
Let's see if I can do that. Are you gonna? Okay, let's see. Well, okay. Here we are in Antarctica. Here's 114. Let me click on it. It says we're doing 96 miles an hour, and we're trying to break away down there. Don't know. Now Todd's got a balloon that's falling pretty close to that.
It's well on its way to making its first lap around the world. Of course, at 70 degrees latitude, it is minus 70 degrees latitude. It goes around the world a lot quicker.
You know, if we could float one at about minus, what is that, minus 10 or whatever you call that? Or no, is it? No, it gets smaller or larger. It gets smaller.
It gets larger.
Huh? It gets larger.
It's negative.
Yeah. Larger. What would that be? 90.
Well, the number is larger, but the negative makes it smaller.
Well, yeah.
It's just math.
Let's just put it this way: find a pole down here. If we can get 5 feet from the pole and circle it, we can make good time around the world.
Oh yeah.
Yeah. All right. So okay, well that's good. You know, I always get something in the mail every day. It's like Christmas.
I think that's one of the reasons I like building stuff is I'm ordering stuff all the time. So it's like Christmas every day. Something cool shows up.
Yeah, these came in today. You know what those are?
Look like B and C attenuators, maybe?
Yeah, that's what they are. Yeah.
Oh.
Yeah, I had to get me some more attenuators. I don't want to blow up my new spectrum analyzer, so I got me some more attenuators. But every day I got some. Hey, I got 100 2N 7002s coming in.
Ooh.
And that's not the little bitty teeny ones. That's not the SO23s. That's the whatever the next size is. I wanted some of the little bit bigger ones to play with. So I got 100 of those MOSFETs coming in, and guess what? They cost me like a penny.
Yeah.
A penny each. So I got 100 of them for $1.23.
Yeah.
Now let's see if anything's inside them when I get them. You know.
I use that for everything. Those are wonderful FETs, Tom. Yeah. Those are great FETs. They can handle some power, and you can use them to switch things, and they make a great RF stage too. Particularly if you're doing a Class E amplifier, they're perfect for that.
Yeah.
My standard to go to is still the old 2N2222.
Oh, that works too. In fact, I think. Let me think, man. I might have to get my book. I've done so many different ones. I'm thinking on 113, W5KB 113, which is flying over China right now. We have the 100 milliwatt amplifier on that one, and it's either using a 2N2222 or it's using the 2N7002. I think it might be using the 2222, but I'll have to look and see. But the reason I ordered those others, I'm gonna redesign and use that MOSFET. I think on some new amps. Probably going to be much more efficient. Hey, let's take a quick standby here for a minute, and then we're going to get started. Hey, we got a satellite station up and working tonight, and we're going to build the curve tracer. So everybody stand by and don't go away. We'll be right back with you.
LDG Electronics provides from QRP to QRO, fixed stations, portable and remote. An LDG tuner will match your radio to your antenna using our lightning-fast proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
Keep your competitive contesting edge with ICOM. ICOM's high-powered base stations cut through the pileups, letting you work the bands and record those contacts. Contest from the comfort of your home or remotely with the RS BA1 app. The IC7851 gives you a new window into the RF world and is HF excellence unparalleled. With faster processors, higher input gain, higher display resolution, and a cleaner signal. It is truly the pinnacle of HF perfection. It has dual receivers, digital IF filters, high-resolution spectrum waterfall. The IC7610 is a direct sampling, software-defined radio that has changed the world's definition of an SDR transceiver. Features include RF direct sampling, 110 dB RMDR, independent dual receivers. Create your own band opening with the IC9700. This transceiver brings direct sampling to the UHF-VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you very busy. It has fast processors, higher input gain, higher display resolution, and a cleaner signal. Included are real-time high-speed spectrum scope and waterfall display, smooth satellite operation with 99 satellite channels, dual watch operation, and full duplex operation in satellite mode. The IC7300 is the high-performance innovative HF transceiver with a compact design, and it will far exceed your expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. Features include RF direct sampling, 15 discrete bandpass filters, a large 4.3-inch color touchscreen, real-time spectrum scope. For more information on ICOM radios, visit www.icomamerica.com/amateur. All right, so we're back. Let me turn the echo off. There we go. So let's do this. Tonight, we've got a couple things to talk about tonight. I'm going to show you the setup for the satellite station I've got working tonight, and you'll hear some contacts on it in a few minutes. I got a little short video on that. Right now, let's do this. You know, I'm always looking for some projects, as I mentioned, and here's a neat little project. It's called a curve tracer. Just built this up. And hey, I actually put some labels on it. How you like that? So, you know, hey, out of the chunk box, I had some of these Teflon cables here, BNC cables, with these really nice Teflon cables. I had the banana plug jacks here, and I had new test leads. And hey, you never throw anything away, right? Hey, you know, power cord came off an old lamp or something. You know, you don't ever throw anything away. Now, I did, fuse. See the fuse holder back here in the back? Look at that. Let's see. Yeah, man. So, I did steal the case, this box. I got this years ago with a QRP antenna tuner kit. And all the parts were in here. So, I dumped all that out in a plastic bag, and I said, you know, this would be the perfect box to build the curve tracer in. So let's do this. Alan talked about this once, probably last year. I'm going to run this quick video that Alan did again about the curve tracer and what it will do. This thing, it is so good for testing solid state devices like diodes, Zener diodes, transistors, LEDs, right on your oscilloscope, and you'll see how it works here. And then I've got pictures of the construction of it, real simple to make. So let me put this on real quick. And then we'll get into the real makeup of it here. So here we go.
All right, we're going to do a video here by request. This came after doing my video on XY mode and Lissajous patterns. And one of the very common uses for using a Lissajous pattern on a scope is to use a circuit like this thing called an octopus. It's literally been around for decades. It's a very simple circuit that applies a current limited voltage across a component. It could be a resistor, a diode, an LED, something like that. And then we basically measure the voltage across the device and the current going through it. And lots of circuits that you can Google, octopus component tester, and you'll get dozens of different variants of circuits. This one I printed out because it was kind of clear. But in the end, you can really kind of simplify that down to a simple circuit like this. Makes it easy to understand. You can basically see we've got a step-down transformer that's just powered off the line. This, it could be a 6.3 volt, the old filament transformer or whatever. All right. And basically we have a current limit resistor and a set of probes that would connect to our device. Okay, so we're basically setting up a current limited voltage, alternating voltage, going through our device under test. And we can connect essentially, from one side of the device to the other, into, say, channel 1 of the scope, and that'll give me the voltage across the device as this test signal is applied. And then if we look at the voltage across the series resistor, that gives me a output voltage that is directly proportional to the current that is flowing. Okay, so very simply, now I've got a signal representing the voltage across the device and the current flowing through it. If we put that in XY mode, we can plot voltage versus current for a given device. Very, very handy. This old Heathkit scope that I have here actually has a component test function, and this is kind of precisely what it does. And so right now I've got the test lead coming from the component test port open, and this is what you get when it's open, because the horizontal axis, the x-axis, is representing the voltage that's being applied across the device. The vertical axis, or vertical deflection, is going to be proportional to the current that's flowing through the device. Well, there's no device, so there's no current. I just got a horizontal bar. If I take and ground, okay, my connection here, I'll just connect it up to ground here. See, what happens is I get a vertical line. Okay, and that makes sense, right? Because as we try to turn the voltage up, okay, across the device, there's no resistance there, so the current just rockets up and down. Okay, so these are two extremes from being open circuit to short circuit. We have these two extremes. So in between there, if we have like a resistor, we'll get kind of a tilted line. If we have like a diode, we'll have maybe an L-shaped line here. So I thought it would be fun to kind of show this. Hey, you can kind of scratch build something very, very simple like this, and that's what I did. I just have an old filament, or actually an old transformer here, and I've just got a series resistor right here, and I'm just connecting up with my probes, and I've got a bunch of components kind of sitting in my little test board over here. So we'll go look at them. So if we go over here to my scope, let's kind of switch this kind of to a regular, just 2-channel mode here, and I've got both channels coming in here. So right now the probe is open. So this voltage here is representing, or this signal is representing the voltage that's being applied to my device. My device is open, so I'm getting no current flow. In fact, what I'll do is I'm going to reduce the scale on these guys and separate them a little bit. So it makes it kind of easy to see. Okay, there's my voltage, no current flowing. If I take my probe and I ground it, okay, then I can see that essentially what happened is my voltage collapsed to 0, and now I've got current flowing. I'm not triggering on it, but that's okay. So now I'm triggering on it there. Okay. So, but that's kind of what's happening there. So let's look at the extremes now. Okay, let's go back to triggering on that again. If we kind of go back to the XY mode, and I'm just going to bring my scales back down, and there's our open circuit waveform. Let's kind of put that right in the center gradical. There's my open circuit waveform. If I ground my probe, my DUT probe, you can see I get my vertical deflection, okay, indicating I've got a short circuit. So if we go across an ordinary silicon diode, okay, I've got one sitting right here, okay. If I go across that diode, okay, and come back here, Now I can see that familiar, diode characteristic. As the voltage goes positive, we go to a point where the diode turns on, and boom, the current goes up. Okay. As the voltage goes negative, okay, across the device, I get no current flowing. So that's essentially what a diode looks like, and that tells me, hey, this diode is good. If the diode was shorted, I'd have a vertical line. If the diode were open, I'd have a horizontal line. So simple little component test. I know my diode is good. All right. Let's look at an LED. Okay. I've got an LED sitting right here. So if I connect this guy up to the LED, and I look back over on the scope, I've got that same characteristic. The difference is that I'm turning on at a larger voltage, right? Typically LEDs have got a larger turn on voltage than, a silicon diode, which might be 0.7 volts. An LED might be 1.5, 2, 2.5, 3 volts, depending on the technology for the diode. Okay. So that tells me that diode is good. Excuse me, that LED is good. All right. So pretty useful. In fact, a good way to look at this, I'm going to switch back to kind of the normal mode here with the scope. Let's go back to change my scales. Okay. I separate the signal out here. Now I can actually see what's happening. Okay. This trace down here is the voltage across the LED. As the voltage is going negative, okay, there's no current flowing. Okay. As the voltage goes positive, it reaches a point where current starts to flow, and the voltage then doesn't increase across the diode anymore. But as we increase the voltage across that stack, of the component and the resistor, okay, then the current actually continues to flow. Now, as the voltage comes back down, okay, goes down below the turn on voltage for the LED, the voltage will continue to go negative, and the current goes off. So those two waveforms now, when you combine them up in the XY mode, you get this kind of, your typical L-shaped curve that you have. That's kind of the characteristic curve in a component tester for an LED. Okay, and so that kind of shows that. If we put a capacitor on here, a capacitor is going to just basically provide some impedance and a phase shift. So that's going to basically, give us an ellipse of some sort. Its size is going to be dependent on its value and the frequency that we're testing it at. So this is kind of an example that, yeah, that's a good capacitor. If it was open, we'd have a flat line. If it was shorted, we'd have a vertical line. The fact that we have an ellipse is enough to tell us, hey, that's a capacitor at least is not open or shorted. So what's interesting is that I found this little glass diode right here. Okay, so I can focus on that. No markings on it, so I stuck that in here. And if we kind of stick our probe on that, okay, and go look at my curve tracer, okay, now I get this characteristic. So what does that mean? Well, this says that as I go forward in voltage, okay, the thing's turning on like a normal diode, so that's my normal forward voltage characteristic. But as I go reverse in voltage, instead of staying with no current flowing, at some point some current does start to flow. That tells me that's a Zener diode. Now, this diode was completely unmarked. I had no idea what it was, but this tells me that it's a Zener and it works. And I can do some further tests to characterize, where that knee voltage is, and I'll label it, and now I know I've got a Zener diode for that voltage. So that's kind of a neat way to determine that. So it's a nice thing to very quickly sort through your junk box of components to see if the diodes are good and if they're Zeners or what they are. You can even use it to kind of look at transistors. I've got a transistor right here. Okay, let's kind of grab the center lead here on this TO92. Okay, I know this happens to be an NPN, but you can kind of even ferret out what it is. So if I connect up to the base lead, which is in the center here, okay, and let's look at each of the junctions. Okay, I'm just going to touch them to ground. Okay, so there's one of the junctions here. Okay, looks like a normal base emitter junction, kind of like a diode, so that's good. If we touch the other one here, okay, kind of get that over there. If I could do this with one hand, there we go. So that's actually, I'm looking at it, it's the base collector junction. Okay, so that one's good. What you may have noticed, let me put the base emitter junction back on here. If we look carefully, we can see that at the very end of the negative side of the base emitter junction, we're starting to get a little bit of breakdown, like a Zener breakdown on the base emitter. And that's actually pretty common. Because of the doping involved, you will get a Zener breakdown at a relatively low voltage if you reverse bias a base emitter junction. And actually, they make pretty decent Zener diodes, so you can certainly use them that way if you current limit them. But this tells me that both the junctions in this little NPN transistor are good, So again, it doesn't tell me much about its gain or other characteristics, but it's a simple way of just verifying that, hey, this thing's not open or shorted or dead. So simple circuit like this, variants that you'll find all over the internet. Again, you can search for octopus component tester or oscilloscope component tester. There's lots of ways you can search and find variants of that schematic. But that's how it works. And you got a scope with XY mode. You got yourself a very simple curve tracer, and really quick to kind of go sorting through your junk box parts. But anyway, thanks for watching, and comments, suggestions.
All right, so hey, he gave us a really good description of a curve tracer, and 50 years ago, I was repairing a lot of radios on the side, and I had a curve tracer, and that was so cool to be able to probe out parts, and it did a pretty good job even with them in the circuit, actually. But it's been many years since I've used one. I thought, well, let me build another one. I want to build something for the show, so we built a curve tracer, and here we go. Again, this is it, and it looks pretty good, I think. It's better than most of the things I build. I tried to at least cosmetically make it look good. And we're going to look at this. I'm just going to show you what it took just to put this together. I have some pictures here, and let me just jump down to them real quick. And let's see, here we go. Okay, well, first I was trying to find a little box to build it in. And I thought, okay, what's something small and that I could put this thing in? And so I thought, okay, hey, I've got hundreds of these old wall warts here, these little transformers. Let me just, bust this thing open and take the guts out of it. And, I'll use the AC part of it in there. And the curve tracer doesn't have but about 3 other parts to go in it. And, mount the jacks and plugs on the outside there, and you can just plug that in on your workbench and hook it to your test equipment. But then I started thinking, okay, all these little wall warts here are switching supplies. They don't really have a transformer in there that converts your 110 volts to like 6 volts or 8 volts or 12 that I needed to run this. They have a switching supply, which means they take that 110 volts right off the bat and they rectify it with a full-way bridge. And, they come out with about 150, 160 volts AC. And then they run a little oscillator at a high frequency. And because of that frequency, then they can have a little bitty transformer. And the transformer in there is probably about ½ inch square. But that's because it's running on a very high frequency. It would not run on 60 hertz. Back in my day, it was called 60 cycles. But anyway, so, I busted that open. I said, okay, well, that idea is not very good. So, okay. So I started getting all my parts together, and I found my little box right there. Went through my junk box and went up in the attic, and I've got tons and tons of parts. I found a transformer there, 110 volts to, I think it had about 17 or 18 volts on secondary center tapped. So I thought, okay, that's good enough. I can just use half the secondary. That's 8 volts, and because the schematics I saw were using a 6-volt transformer, but I think you could use anything, probably as long as it's not more than your scope can handle. I think I could have easily used a 30, 40, 50 volt there, but then again, that might not be good for some components that you're testing. But anyway, hey, the banana jack's right there. I, got my old fuse box out and opened it up, got my fuse holder out, got me a little LED right there that I'm going to put in here. I showed you the Teflon coated BNCs that will connect to the scope. So there we are. I just kind of marked it out and laid it out. It's going to be pretty tight with that transformer in that box, but I started laying it out and drilling holes in it. and kind of make everything fit. And so there's another shot at it, and there's the one with the parts starting to lay in there. And the little brown square board on the right side there, it's just a little perf board to hold the resistors that I needed to use. And we put 3 resistors in there. That's basically the entire circuitry. It's about 3 resistors, but we used that little board there, and we mounted it down in the bottom on some standoffs to hold our parts. There's a look at it with the transformer more or less laying inside there. Shot of the back. Now, right there, that's not the fuse holder. That is a clamp. That is a plastic clamp that goes in a hole that your AC power lead goes through, and that's supposed to grab it and hold it. Well, I made the hole a little too big, therefore it wouldn't clamp down tight enough on the wire. And I needed to get a fuse in there anyway, so I just put a fuse holder right there. So there's a kind of a shot at it right there, holding it there. You can see the BNC connectors and the test probes we got. Again, another shot looking down in it. Let's see. Okay, so, and there it is, just setting up on top of a little frequency counter there and hooked to my scope there. Well, when I hooked it up, I wasn't having a lot of good luck on getting the waveforms, like the L and the straight line and so forth. And it just wasn't working very well for me, and I don't know. But I was getting that. If you remember, if you looked at Alan's video, you saw one of those is actually the voltage and one of them is actually the current. So I was seeing that, so I knew it was working. And then I started thinking, okay, I got to go in the XY mode. Now, will a new digital oscilloscope go in the XY mode or add? It has to add the two together. So I started looking, and Bill, I did find that in the menu, there is a menu. You can scroll down and select XY mode. I selected XY mode, and that more or less fixed my problem. Let's see, there's another shot of this stuff in here. You look to the right, you see a little black spot on the right side down in the bottom of the box. That's actually a piece of insulation that I put above that perf board, because if you notice, that fuse holder is really, really close to the little circuit board that's underneath there. And I didn't want something, coming loose and touching that 110 volt there. But anyway, that's kind of it. And of course, there's the patterns that you get when you're checking various components there. The tilted line is like resistance. You can see the other lines there, that whether it's a Zener diode or a regular diode and so forth. So that's pretty neat what this thing does. And there they are again. Bottom left corner there is a checking of a capacitor. And it's just a really neat little box to build. I don't know if I'll ever use it, but now I've got me one. So I don't know. What do you think? What do you think, guys? What do you think, Glenn? Should I use it?
Yeah, I think it's pretty cool.
That's great. Now, the XY inputs on the digital scope is what, channel 1 and channel 2, or do they have?
Yeah, it's channel 1 and channel 2. It combines them or it adds them somehow. That's just called XY mode. So okay. go to menu and turn a little knob and scroll right down to XY mode, XY, and just hit enter, and you're there. So
we used to use XY mode a whole lot when you're in the radio teletype, because you were tracking your mark and space frequency, or the mark and space detect.
Yeah.
And you would see the signal, switch vertical and horizontal.
Right. Yep.
And a kind of an oval pattern, so that you could actually tune.
And some of the RIDI decoder programs do that digitally on them, like MixW, for example,
right,
has that pattern on it. So just for old timey sakes.
And
Um,
it's easy to tune when you do it that way too.
Well, you almost needed that to tune it, really. I mean, I worked teletype for many years. In fact, in the Air Force, I went to teletype school, and I built a terminal unit for teletype back then with the scope tube in it. And you're right. If it was wide shift 850, you'd see a plus like this on the screen, and man, when that thing, it'd be hitting like this, and you knew you got it tuned in. Now 170 shift is more like 170 shift. Always was kind of like that, 180 shift was like that, 170 like that. But man, you could turn that tuning dial and watch that scope, and you knew exactly when you had them tuned in.
Yeah.
Yeah.
Now the neat thing is, if you've watched any sci-fi movie, particularly older ones, you'll always see a Lissajous pattern in the background.
Yeah.
On a scope, and even in some of the more recent movies, they always have one back there doing its thing, and that's just an XY pattern.
Yeah. Hey, speaking of movies, hey Bill, I don't think you were with us last week. Did you see the special event station that I talked about? You probably didn't see it.
No.
Yeah, there's a special event station. Get the QSL card. It's the what was it, Glenn? The anniversary of the making of the movie, the Japanese movie Godzilla.
Yeah.
That was a special event station. You got this nice QSL card with Godzilla on it and everything, man. That was kind of cool.
Excellent.
So we need to come up with some special events, guys. Okay. Well, hey, there it is. That's a little project we did tonight. Boy, I'd like to do a project every week. It's just I can't seem to find time. It's so easy to throw together, simple shortwave receivers and things like that.
Well, you should look at that new chip they've got out. It's the 4732 and that series.
Yeah.
They're a single chip sideband receiver.
Yeah, that's probably a game changer there. I have built some sideband receivers before, but man, everything in one chip there, that's pretty good,
Yeah.
Who makes that chip? You say it's 4732?
I'm pretty sure it's the SI folks, whoever bought up.
You can buy that. You can buy that radio, right? With it, there's a radio out there that chip in it. You can buy.
I actually have that kit here. I just haven't had time to assemble it.
I bought one of those radios that had that chip in it. I didn't like the sound. I didn't like it. It sounded really tinny, and I wasn't happy with it. I sent it back. But, maybe you ought to build something with that chip.
Well, they keep expanding and improving on that line. I think they're up to the 4735 right now.
Yeah. All right, guys, that was the curve tracer. Hope you enjoyed. Nice piece of test equipment, and it has been around a while. You saw on Alan's video, it's called an octopus schematic, but check curve tracer, octopus. It goes by several different names, and I actually had it built into an old 5-inch scope when I was doing that repair work. I actually built one and put it inside the scope. It was kind of neat to have. All right. Well, okay, let's move on here, and let's see what's about.
Hey, Tom, did you ever have a Huntron?
What was that?
Or did you ever see a Huntron unit?
What's that?
It was a component tester, loosely based on a curve tracer, and you put a probe down on a live circuit. Well, it didn't have to be live, but you put it on the components in the circuit, and you could tell what component was and whether it was good. It was called the Huntron.
Yeah.
But it had different curve patterns on your scope.
Yeah. Well, this curve tracer.
I used to have one of those, and it was invaluable.
It used to work fairly.
It was great for troubleshooting blown out components.
Yeah. Well, even the curve tracer, when I used it years ago, it worked very well in radios that were in the circuit. Of course, if a component's in the circuit, it's got other components around it. You might get some variation or change in that picture, but you could pretty much tell if a part was shorted or open. even though it was in the circuit. So it made troubleshooting just very, very fast. You didn't have to, pull a transistor out and, check it with it out of the circuit. Yeah. Hey, let's talk a minute about satellite. Now, I know Glenn's got him a 9700. He's going to get back on satellite soon. And
It's still in the box.
Yeah, I finally got mine out. So
My 3D printer is still in the box.
let's talk a minute about satellite. Now, I got a little just quickie here to show you on my satellite experience today. Now, I used to operate a lot of satellite about probably 15 years ago. I was in it pretty good. But then I kind of got out of it, particularly after I moved to this house right here. We've been here about over 9 years now, so it's been about 9 or 10 years since I've actually got into it. But back in early days, there were some really easy satellites to work. Some of the FM birds, I forget what they were now. AO50, I think, was one of the easy ones to work, man. You didn't even need a radio, man. If you had a filling in your tooth, you could just hook a wire on it and look up in the sky, man. When AO50 came by, you could talk to it. That's how easy it was back then. I always hated the sideband or the linear. Always hated the linear birds.
Transponders,
They were much more difficult to tune and work and everything.
That was actually my first one was AO7, way back when.
Yeah, AO7 is still flying actually right now. I saw it
that
today.
was interesting. I put a preamp in my HW101 on 10 meters so I could work that bird. And interestingly enough, over the years, the battery shorted out or something. And then here recently, within the past, 10 years or something, the batteries opened back up. And so it's live during sunlight.
The NiCad battery had a crystal, just one of those nickel shorts on it, and it finally let loose after about 40 years.
Yeah.
I was involved in the aerial test. They took AO6 or AO7, one of the two. When I was in high school, they were flying it over the Midwest, test it before they launched it into space. And I actually was one of the several hundred people that that made contact through that flying in a Cessna.
Oh, cool.
And that was my first introduction to satellites. And then to actually work it when it was in space after I'd done the aerial test was just a phenomenal experience. But
those
were the good old days.
But it was only so I could hear my downlink. I never worked anybody through it. But I did hear my downlink.
All right, well, let me show you what I've got here.
I have the log of that first flight test that they did over the Midwest before they launched it.
So, guys, here's my satellite station here, and I don't have anything really elaborate, but let's see, how do I do this? I've got the pictures loaded crazy tonight. There we go. I've got a pretty simple, small antennas here. I've got a single, I think that's either 11 or a 13 element 2-meter antenna right there, and on the other side there, it's about 11 element 440 antenna, and I've got 2 rotors there. Right there by my head is the azimuth rotor, and then at the very top I've got an elevation rotor that moves the antennas up and down. So, I have to manually move them here, and that's one of my problems I had tonight. I used to be pretty good at this when I was following a satellite and making contacts. I could work the azimuth and elevation rotor and kind of keep it on the bird as we were following it. But I had a little difficulty tonight. And also there's some calibration that I need to do within the software. I'm running a software called SatPC32. It's supposed to be one of the best ones out there. And it'll actually tell you when, and it'll track the satellites as they come over, and it'll actually change the Doppler shift as the satellite is moving. It actually tunes your radio and changes the Doppler shift and keeps you on frequency. So there's my antennas, pretty basic. And up there, we talked about this before. If those antennas are aimed directly west, it goes through that roof and through that attic. And if the antennas there are aimed south, it goes through another roof and through the attic. So I'm pretty clear I'm pretty clear up high above. I'm pretty clear to the north, and I'm fairly clear to the east. But it is working. Let's see. I've got another picture. Let's see. That is not the picture I'm wanting. There's a satellite. There's my satellite station, and what I had to do, guys, I'm running out of room on my desk. My desk where my operating position is, I don't have room for all this. And I had to take part of the end of the workbench. So I turned the end of the workbench to set up a second station. So if you look at the monitor up there, the PC monitor up there, that's the program called SatPC32. Below that on the shelf, that first radio to the left with the brownish orange color background, that's a TS570, and that's my remote base. We've shown you and we played with the remote base on here. So that's my remote base. And then right to the right of that, there's a ICOM IC9700 right in the center. And then to the right of that is the azimuth rotor, and to the right of that on the very end there is the elevation rotor. So while I'm trying to make contacts, I'm reading the frequency, and I'm manually reading the frequency on the satellite program above, and I'm actually turning the rotor and aiming the rotor during its travel. Let's see what this other picture is. Oh, well, okay, that goes back to our other project here. So, hey, here's just a quick clip. This is, again, this was basically my first contact getting it even working. It's not perfected yet. I'm not aiming it well yet. And some of the birds, that they weren't good passes. If the passes are low, down 1 or 2 degrees high, you're not going to hear it very well. So some of these passes may have been low. Some of the passes may have been on the other side of my air conditioning system in the attic. Who knows? I'm going to play a little video for you here. It's a real short video that shows you just how this little station here, simple station, can hear some of the satellites. So here we go. I'm going to try to see if this will play. Here we go. It's about 2 minutes long.
73, my friend. 70.
This is Whiskey 5, Kilo Uniform Bravo.
Whiskey 5, Uniform Bravo, Kilo November 4, Zulu Alpha Alpha, EL 96.
Roger, Roger. Echo Mike 55. Thank you.
This is Kilo Mike 4, Romeo Yankee, November, EL 96. EL 96. 4, Romeo. JKM4ZA. KM4RYN, KO4, Beachside. In November, you. KM4 is KA, KM4 is UK. Good copy, Ed. 76, yeah, Mike, totally Mike, Fox, Mike, UK, I believe it. This is Kilo Mike 4, Romeo Yankee November, EO 96. NA6Y, EL 97. EO 97. This is Kilo Mike 4, Romeo Yankee November, EO 96. NA6Y.
All right. So you can see it was working. A little noisy. Various reasons for noise. I can't explain them all, but hey, I've got pretty small antennas. But hey, at times, if the satellite's in a good position and I got good line of sight, it can be loud and clear. You heard a couple times it got loud and clear. Now, as the satellite's moving up there, it's also tumbling or rolling a little bit. And what that's doing, that's changing the polarity of the signal from vertical polarization to horizontal polarization. And all I have up is just single vertical polarization antennas. So as that satellite maybe tumbles a little bit, you're going to hear it fade in and then come back and fade out and in like that. If you've seen guys working satellite with a handy-talkie and a hand antenna, a Yagi hand antenna, you probably have noticed they'll twist that antenna, they'll turn it horizontal, vertical. And it's real easy to turn it until you hear the loudest, clearest signal. And then when it starts tumbling and changing up there, you can just kind of follow it with your hand. And that helps a whole lot. Having fixed polarity antennas is not the best way. I could put the cross antennas up there, but that's a whole lot more antenna, and I don't really want to go to the expense of all that right now. So I've kind of got the station working. The program is controlling the radio. It's setting the frequencies. It's following all the satellites and so forth. So one of the things I've got to do is I've got to calibrate each satellite. And if I get a good pass, I can actually hear myself. When I talk, I can actually hear myself come back on the other receiver. And on the SAT PC program, there's some buttons that you can click that will actually move your frequency. And I can hear myself and I can see myself on the spectrum analyzer. I may be tuned here, but I hear myself coming back over here, and I can hit that little button and I can move my frequency back down and almost get it lined up. But it takes time to get all that straightened out. So.
Yeah, it takes a little bit of time to get squared away. Now,
Yeah.
as far as your manual rotator thing, let me throw this in here. That was one of the things I really wanted to get going in my first book, and I had that done for the Yaesu azimuth elevation controllers. And it would probably work on your little split setup there as well. And that's actually going to be reprised in my current book, and it's going to be all updated and a little bit modernized. And I'm actually, it'll run on Ham Radio Deluxe or the SAT PC 32. And remember, there's still a free version of Ham Radio Deluxe that you can use.
Yeah.
So
I've thought about trying to automate it. I don't know, Glenn. I tell you, there are so many wires. Right? You wonder where do all these wires come from. If you look back here behind that radio right now, there's only like 382 wires back here right now.
Oh, you got the miniature version.
Yeah. And I've got a little PC set up. I think I'm using 4 or 5 USB ports on it, right now to make everything work.
Oh, yeah.
Man. Oh,
And,
man.
yeah. And that's the thing. But you were talking about the antennas. I actually bought a pair of Yagis from a gentleman at Dayton a number of years back. They're wire Yagis or quads.
Yeah, the quads.
Actually, they're Scorpion 88s is the model number, and they're actually 2 meter and 440 quads on one PVC frame. And I actually up on my roof, I have one phased vertically and one phased horizontally, and then of course I've got the phasing cable between the two.
Yeah.
So I've got both horizontal and vertical polarization simultaneously with mine.
Yeah, and that will help you out a whole lot too.
Yeah, it did.
Yeah.
Because I had the Kenwood, the Yaesu 847, and I sold it so I could get the 9700 and get that all set up. And I'm, like I say, it's still in the box.
All right. Well, what else is new? Anything going on, guys? I have kind of changed the timing of the show here to try to end about 9:30 instead of 10 o'clock at night. That means I can get to popcorn a little sooner.
Amen.
And what I'm doing is I'm leaving the 30 minutes of music on the front, and this is what we send out, the 2 hours on shortwave. The shortwave show has the 30 minutes of music and then an hour and a half of the show. We have a 2 hour slot on shortwave. So that's kind of the format we've gone to right now. I will start opening the phone lines back up or Zoom back up again here soon. When we have a little bit shorter show, we'll try to get people back involved here.
And see, for me, after the first of the year, I'll start another research phase, and I'll start videoing a lot of what I'm doing.
Yeah. Again, guys, if anybody out there, and I'm pleading for you, if anybody out there has any neat projects you built, or some new antennas, or just doing something, or hey, if you want to, hey, come on here and give us a segment of something that people might enjoy looking at, and that way the show won't be boring, every week. Hopefully, it's not been boring.
Yeah, just my
every
segments will be boring.
Yeah, I hope it hadn't been boring every week. Hey, guys, we're coming up with Thanksgiving. Let me tell you, out of all the holidays all my life, Thanksgiving is and was my favorite holiday. Out of all the holidays, I don't know why. I guess I remember, the lunches or dinners, with the whole family and the grandmothers and the cousins and everybody. As you get older, that stuff goes away.
Yeah,
your kids get married, they move out, they move to Texas, and I see Chris in the chat room here. He's in Texas right now. Your kids get married, they move away, and then they got other families, and then you got a child. And I know as we were going through life, we had to, maybe this Thanksgiving we'd spend with this family, and Christmas we'd spend with this family, and next year we'd spend Christmas with this one and Thanksgiving with that one, and But as you get older, you can just say, hey, we're having it at my house now, and
exactly.
They'll come over just because we do all the cooking. This year it's going to be different. I think our Thanksgiving may be Saturday this year, and because we've got family and grandkids that are out, they've got other places they got to be. So no big deal. I'll have my Thanksgiving probably Saturday, but still, it's going to be a special holiday, for me.
Yeah, I love Thanksgiving. I love Christmas, but like you, Thanksgiving kind of means a little bit more to me. I don't have family here, but I still cook myself a Thanksgiving dinner, and of course this year I'm going to be spending Thanksgiving with some friends. So yeah, Thanksgiving is kind of more of a special holiday because, like you say, that was when the whole family got together, and that was so fun back then.
Yeah, and most of that family is gone now, so
yeah,
they've either died and left us, or they're they got their own families, and boy, things change, but it's still a good holiday. Still a good holiday.
The majority of my family is out there in the Dallas area, so
yeah, okay. Well, hey, let me just make an announcement here before we close the show up. If you're listening out there on shortwave, WBCQ, we really appreciate you listening. The show tonight has been about ham radio. The show is called Amateur Radio Roundtable, and we're a weekly show. You can find us on shortwave every Thursday on shortwave from 5 to 7 p.m. Eastern Time on 7490. And if you'd like to join us, if you have the internet, you can actually join our show live on Tuesdays. And our show is at 9 p.m. Eastern Time on every Tuesday. So you can join us by going to w5kub.com. And that's our official site. That's where we have the chat room. We do not use the YouTube chat room. We don't have any real control over the YouTube chat room. It's just been a lot nicer for us to have our own chat room. Plus, Hambot runs on our own chat room. Hambot would not run on the YouTube chat room. So anyway, hey, we're glad to have you tonight. Join us on Tuesdays if you can. Join us again on Thursdays every week. Remember, you want to listen to us on podcasts. We've got a podcast out there on all the podcast carriers. It's called Amateur Radio Roundtable. You can just do a search and you can find it there. You can hear us on WBCQ every Thursday out there. And oh man, let's see. Hey, don't forget to join our Facebook group. Please join our Facebook group, and our Facebook group is called W5KUB. And also, if you will, hit that subscribe button. Again, I'm helping you right there. I'm pointing toward the subscribe button. Please hit that subscribe button. If you're tracking our balloons, hopefully W5KUB 115 will be launched tomorrow morning from Antarctica. And let's watch for it, and let's see. We've got 3 others up right now, and let's see where they are real quick. Let me put them on here. So we've got 3 balloons flying right now, and I don't know if you can see them in it. Yeah, you can see them on here.
I see one over Saudi Arabia area.
It's kind of small.
And there's the one over, actually near Japan.
Yeah, they're kind of small. We got the one down by Antarctica. It'll have a second flight down there with it, hopefully tomorrow. We've got one right off the coast of. What is that going over? What is that over Japan now?
Looks like it's over Japan. Yeah.
Let me look. Let me look at that and see. Let me just zoom in there. Oh, yeah, we're just to the south of Japan a little bit right there, it looks like.
Yeah, that thing's moving.
Yeah, so, okay. And then we've got the other one that's somewhere down around Saudi Arabia right now. So we got a bunch in the air. And Glenn, the one flying Glenn's call, KW5GP, is down in Antarctica. And let's see how fast you're moving, Glenn. Let's see. Oh, that's the wrong one. Wrong one.
Be the fastest I've moved in years.
That's the wrong one. Let me see how fast you're moving down here. You are moving.
Wrong one.
90. That's it.
There you go. Yeah,
96 miles per hour, Glenn. You're doing nearly 100. You're doing nearly 100 miles per hour.
That's pretty good.
Wow.
You know what? But we really have to give Todd credit because, like you were saying, the weather down there is never optimal to launch balloons. And
yeah.
So far, he has been able to get every one of them up safely and, like you say, to float altitude. And, you know, they're all hanging in there. And that's just really amazing.
Yeah, well, he did the weather prediction 2 or 3 days ago. He said Wednesday looks like it's going to be the best day to launch. So he knew a couple of days out what day to launch. So he's really good on his weather stuff. And hopefully he can find a little hole up there in all those clouds, and we can get that balloon there through tomorrow. And let's just see what
he did
happens.
have one mishap. A calm day in that area is very rare because there's no trees at all. The good news is it's not going to snag on a tree. It might get caught by a penguin, but
yeah, I guess, man. You know,
but he did have one mishap that wrecked the antenna on one of them, and he had to use my spare antenna.
Oh, okay.
Well, that at least it was recoverable.
Well, I'll tell you, I hope he went inside to hook that antenna. I'd hate to try to do something out there in the cold, man. Yeah.
I developed on mine. I actually had the antenna with a little connector on it, a little JST connector that would plug into the board, so he didn't have to solder anything.
Oh, okay. That's cool. Well,
but they do have a lab there, a solder lab.
Do you have any idea of what process he's using to try to seal the balloon or anything? Just tape, probably.
Kapton tape and the hole punch through it.
Yeah.
But he just folds it over, puts Kapton tape over it, and then punches a tiny little hole through it. I sent a special hole punch down with him that's got like an 1/8 inch.
Yeah, I've got
hole
one of those.
on it.
So, Bill, what I did
What
on my balloons I sent down, I put maybe a 4-foot string on there, and what I did, I taped it down to one of the seams of one of the balloons, and then I took it and went through the hole in the filler, and that way, if it broke out of the filler or something, hopefully it would still be attached to the balloon. I mean, kind of as a safety deal. So we'll see. And I saw that technique from.
I think.
Yeah, I saw that technique from one of the balloon companies. They actually sent some balloons to me that had the string attached to them, and they had it actually, the string actually taped to the balloon, and looked like it held pretty good. So I did do the hole, but I also did the secondary tape it to the balloon.
Well, he's got three three more trackers to go, and I think the last one is going to be a 10-meter one. So it ought to be very interesting to see how well that performs.
Oh, that's going to be
I
fun.
tell you, 10 meters is hot. I'm looking at it and comparing it to 20. It looks like it's got double the number of reports on it. I mean, it's just hot, and
I'm amazing.
Yeah.
I'm really amazed at how far these are reaching from the Antarctica clear to the northern hemisphere. We're getting a lot of northern hemisphere reports in all over the U.S., Alaska, even as Europe, China. It's just amazing how many people are receiving it in the northern hemisphere on just 20 milliwatts.
yeah.
No, Mark. None of them have been lost. One had an issue because it was beat up on launch, but it is still reported. The K4UAH-2 is the one that
So
he had
what
a high
about
wind situation. And
what about the APRS only? Wasn't there one launched APRS only?
oh, that one, it's still flying. There's just no APRS stations except Newmeyer Station to receive it. If it does manage, that's K4UAH-3. That's probably the one Mark is referring to in the chat room.
Yeah.
The K4UAH-3 is an APRS on 2 meters, and they got great range far beyond line of sight, but there's no other people listening for it. I'm going to try and contact KC4USB and see if they can monitor 2-meter APRS. Now that I've found an email path to get a hold of them, but it's like a day or two delay. But it's probably circling around just like these are, in a very similar manner.
It might show up in a couple months somewhere.
But I think as the season progresses, some of these may kick out of the polar region and actually end up crossing across Argentina and Australia and New Zealand and Chile and
Bill, I don't know.
Africa. So.
I don't know if you followed my friend Michael AA6 DY. He launched one. It went below the equator. It went below the equator, and it went all the way down to I think Peru, and it went across central South America. And now it's starting to kind of aim back up to the northeast. I don't know if it's going to stay down here, if it's going to come back up, or what's going to happen. But that's one of the first one I've seen do that, really.
NOB dash 1, I forget what number, NOB 20 or something. It is flying. It was launched from Germany. It's been up almost half a year or so, and it ended up in the southern hemisphere, and it's been circling the southern hemisphere for months.
Yeah.
You see the one that says NOB.
Yeah.
That was launched by a German station.
So here, guys, here's if you want to follow these, you can follow them on our website W5KUB, and click on balloon, or actually the URL is called ham-tv.com/balloon, or you can get there by going to W5KUB. But so the left balloon, the left one here was launched 6 days ago. That's the one flying in Antarctica now. The one that says 3 days, it hadn't been launched yet. I got to reset the counter. It's going to be launched tomorrow. But we've got maps on here where you can see them. If you scroll on down, you can. This is what's amazing me right here. Look at this one here on the left. W5 KUB 112. It's been up 164 days. That's almost a half a year, man. You know, almost a half a year. So
that's
just,
really impressive.
Yeah, it is.
For a little, the little Yokohama balloons.
Yeah, yeah. But again, I've got tracking on here that you can actually see them here, and you can follow them here on this page if you want to. All right, guys, it is time to shut down. We will see you next week, everybody. Thank you for being with us. We had a great time tonight. Good to see you on here, Bill and Glenn, and have a happy Thanksgiving.
Yeah, you guys do too.
We will we'll see you maybe next week on here if the creek don't rise. 73 to everybody. Had a good time tonight. 73.